Assalamualaikum and very good day to you all. I'm Omar from FTK, JTKE. So today we're going to look into the basic law. So basically last time we already looked into several topics. So now we're going to look into series resistor and voltage division and parallel resistor and current division. What is a series resistor? So we can say that the series resistor is the resistor that connected uh, in series. Let's say we have 3 or 4 resistor, 2 or 3 resistor connected in series. So then that means the total resistor for all series resistor will be the sum of it. So that means you just sum all the value of the resistor that connected in series. So let's say for example if we have the let's say for example we have the resistor that connected in series. Let's say like this. So let's say this one is R1, R2 and R3. So the total resistor will be R equivalent, which is R1 plus R2 plus R3. So this is the definition of the series resistor. For the series resistor, all the current that passing through this will be equal for each of this resistor. Okay, so from this we can determine the value of voltage for each resistor. Let's say if we have the circle like this, let's say let's say if we have the circle like this, we have 2 resistor that connected in series, and this is R1 and this is R2 and this is the voltage. Voltage. So we can say that the voltage for both R1 and R2 will be equals to V. But voltage in R1 and voltage across R2 is equals to VR1 and VR2. Let's say we have this is VR1 and this is the VR2, and VR1 we can find its R1 divided by R1 plus R2 times with the V, times with the V. This is for the R1. Same with the R2. If you want to determine the value of voltage across the resistor R2, then VR2 is equals to VR2 is equals to R2 divided by R1 plus R2 times with the V, the voltage at the supply. Okay, so this is for the series resistor and the voltage division. Okay, for the parallel resistor, let's say if we have the resistor that connected in series. Let's say we got 2 resistors, R1 and R2. So the total of resistor, the equivalent resistor that we can determine should be, okay, let's say we combine it together, R equivalent. So this R equivalent will be 1 over R1 plus 1 over R2 and power of minus 1, which is 1 over. So the actual equation is like this: 1 over R equivalent is equals to 1 over R1 plus 1 over R2. Okay, if we got more resistor, then we have we need to add another some more resistor in the equation. So from this we can get this one will move over there and this one is moving into this side. Okay, so then we will have R equivalent equals to 1 over 1 over R1 plus 1 over R2. Okay, so and this one is equals to 1 over R1 plus 1 over R2 minus 1, same with the top one. Okay, same with the top one. Right, so this is the basic equation for the parallel resistor. Okay, then from that we can, let's say if we have the circuit that have resistor in parallel, then let's say we have circuit this, we got the voltage supply, and then we got first resistor R1, and then we got the second resistor R2. Okay, V1. So from this we can see that the voltage across R1 and the voltage across R2 is same as the voltage supply. Okay, so at this point and this point is the V. Okay, V plus, V minus. Okay, same with the R2. Okay, so from this we can find the value of current that passing through R1 and R2. So first we need to determine the value of current for the whole circuit. Okay, which means we need to simplify our circuit from two resistor to only one resistor, which is equivalent resistor. Okay, and this one is 1 over R1 plus 1 over R2 power of minus 1. Okay, so once we get this, we can determine the current. So I is equals to V over R equivalent. Okay, so from this we can each get the value of I1, which is current that passing through R1, and also I2, which the current that passing through R2. Okay, so I1 is equals to R2 over R1 plus R2 times with the I. Okay, on the other hand, for I2 is equals to R1 over R1 plus R2 times with the I. Okay, so this is two equations that you need to remember. Okay, so this is basically for parallel resistor and the current division. Okay, so now we already understand about the voltage division and series resistor, and also current division and parallel resistor. Okay, alright, next let's do the exercise. Since we already know how to determine the value of equivalent resistance for series and parallel resistor. Okay, so first thing what we need to do is try to understand this arrangement of resistor. If we look into here, we can see that this value of resistor, 1 ohm resistor and 5 ohm resistor, we can add it together. Okay, make it one resistor only. So okay, so we can start with combine together this resistor 1 ohm and 5 ohm. Okay, so let's say this is the first work that we need to do. So that's mean let's say R1 is equals to 1 ohm resistor add with the 5 ohm resistor, so we will have 6 ohm resistor. Okay, so now for the R1 we already have, so let's say this is R1. Okay, so from this then we can see that we have to combine this one together before resistor 6 ohm and 3 ohms, make it single resistor. So this is, let's say this one is R2. Okay, so R2 is equals to 1 over 6 plus 1 over 3 power of minus 1. Okay, or is 3 times 6 over 3 plus 6. So this will be 18 over 9 or 2 ohm. Okay? So we got 2 ohm. Okay, so this one will be 2 ohm. Okay? So for R2 it will be 2 ohm. So now we can do this combination, okay, between 2 ohm and 2 ohm resistor in the R2. Okay, so let's say this one is R3. Okay, so the for R3 is 2 ohm resistor that's connected in series with another 2 ohm resistor that we already solved in here, okay, before that. So this will be 4 ohm. Okay, so after that, let's redraw the circuit. So we have resistor 4 ohms, and then we're going to have resistor 4 ohms. This is 4 ohm, and this one is 4 ohms as well, and then another resistor connected in parallel, 2 ohms. No, sorry, 6 ohms. We have 6 ohms. This is 6 ohm in the R1. Okay, and then final one is resistor 8 ohm. Okay, and you need to find the R equivalent total. Okay, now what we can do is to combine these two parallel resistors together. Okay, let's say this one is R4. Okay, R4. Okay, so R4 is equals to 1 over 4 plus 1 over 6, or 4 times 6 divided by 4 plus 6. So this one will be 4 times 6 is 24. So 24 over 10. So we will have 24 over 10, or if we simplify this, we will get what is it? 24, 12. 12 over 5. Okay, resistor. Okay, finally, we're going to have the we need to combine this one, all three resistor, 4 ohms, 12 over 5 ohms in here, and then 8 ohm. So this will be R equivalent. Okay, so all of this connected in series. So R equivalent is equals to 4 ohm resistor, this one, plus with the 12 over 5 ohm, plus with the 8 ohm. 8 ohm. So then we will have 4 plus 8 is 12. Okay, 12 plus 2.4, 12, 14.4. So we have 14.4 ohms and resistor. Okay, so hope you understand how to do that. So let's you can try to do it and see how you get the result. Okay, so that's it for this time, and see you again.